This metal is so hard, most machines can't even shape it. And what it goes through to be made is even more extreme. It can survive extreme heat, resist wear, and is used in some of the most brutal conditions on Earth. But how is it actually made? Welcome to Made in Reality, the truth behind how things are made. The metal we're talking about is tungsten. It's not just strong, it's one of the hardest and most heat-resistant metals known to man. Tungsten has the highest melting point of any metal, over 3,400 degrees Celsius. That's hotter than lava. Hot enough to destroy most materials instantly. Because of that, tungsten is used in rocket engines, military-grade equipment, industrial cutting tools, and even light bulb filaments. But here's the problem. Tungsten is so hard to work with that you can't just melt and shape it like normal metals. So, how do they do it? Most metals fail under extreme conditions. They melt, bend, or break. But tungsten is different. It doesn't just survive heat, it thrives in it. In fact, tungsten is used in environments where failure could mean millions in damage, or even lives at risk. From aerospace engineering to heavy industrial cutting, this metal is trusted where nothing else works. And that's exactly why its production process is so extreme. Everything starts deep underground. Tungsten isn't found as pure metal. It comes from minerals like wolframite and scheelite. Massive mining operations extract these ores using heavy machinery and drilling systems. Once collected, the rocks are crushed into smaller pieces to prepare them for processing. Deep underground, massive machines drill into the Earth's surface, breaking apart solid rock that has formed over millions of years. These mining operations are not simple. They involve heavy explosives, precision drilling, and constant risk. Workers operate in extreme environments, surrounded by dust, heat, and noise. At this stage, it still looks like ordinary stone, but inside, it contains one of the toughest materials on Earth. Next, the crushed ore goes through a separation process. Using gravity, flotation, and chemicals, the valuable tungsten minerals are separated from waste. This creates a concentrated tungsten ore. At this stage, tons of raw material are reduced into something far more valuable. But the process requires precision. Even a small inefficiency can result in massive losses, but it's still not pure. To turn it into usable metal, it needs to go through intense chemical processing. The concentrate is treated with chemicals to extract tungsten in a usable form. This process produces ammonium paratungstate, or APT. It's a white crystalline powder, and this is where things start to get serious. APT is then heated and converted into tungsten oxide. This transformation is critical because this is where raw material begins to resemble a refined product. It's no longer rock. It's engineered material. At this point, we're no longer dealing with rock. We're getting closer to pure metal. Now comes one of the most critical steps. The tungsten oxide is placed inside a furnace and exposed to hydrogen gas at extremely high temperatures. This removes the oxygen, leaving behind pure tungsten powder, not solid metal, powder. Because remember, tungsten is too difficult to melt normally. But here's what makes tungsten even more difficult. Even after it becomes pure metal, it's still incredibly hard to shape. Most metals can be melted and poured into molds. Tungsten can't. Its melting point is so high that even industrial furnaces struggle to handle it. So instead of melting, engineers had to invent an entirely different way to form it. So instead of casting it like other metals, it's formed using a completely different method. This is where tungsten becomes truly unique. The powder is compressed under high pressure into solid shapes. Then it's heated again, but not to the point of melting. Instead, it goes through a process called sintering. During sintering, the particles bond together at extremely high temperatures without fully liquefying. This method allows tungsten to keep its structure while still becoming solid and usable. This creates a dense, solid piece of tungsten. No melting, no pouring, just pure pressure and heat. Now that tungsten is solid. It still isn't easy to shape. Normal cutting tools won't work. So manufacturers use diamond tools, advanced grinding systems, and precision machining. Every step is slow, controlled, and expensive, because one mistake can destroy the material. In rocket engines, temperatures can exceed thousands of degrees. At that level, most materials would instantly fail. But tungsten holds its structure. That's why it's used in components where durability is not optional. It's critical. The same goes for industrial cutting tools, where tungsten can slice through materials that would destroy ordinary metals. Once finished, tungsten is used in extreme environments, rocket nozzles exposed to intense heat, drill bits cutting through solid rock, military and aerospace components, and high-performance industrial tools. This is a metal built for conditions where failure is not an option. Tungsten isn't just strong. It's engineered through one of the most extreme processes in the world. And this is what it really takes to create one of the hardest metals ever made. From raw rock deep underground to one of the most durable materials on Earth. Every step is designed to overcome its extreme nature. Because in reality, some materials aren't just made, they're engineered to survive the impossible.